All right, one last video for you. This one is on interpreting confidence intervals, or more technically, or more accurately, I should say, visually interpreting confidence intervals. You'll often see confidence interval graphs in research articles. So we'll go about some strategy. We'll talk about some strategies that you can use to better interpret them. So first thing with confidence interval graphs, it's really important to have an understanding of what exactly you're looking at. So you want to read the figure caption pretty closely. Sometimes graphs use confidence intervals. Sometimes the bars represent just the margin of error. I've noticed that in the more neuroscience-y areas, they often do represent margin of error rather than confidence interval. So that's it's important to know what you're looking at. Most commonly, a graph will focus on bars around each mean, but it doesn't transmit information about whether you could reject the null hypothesis very well. So there are two different kinds of confidence intervals we could look at. First, a confidence interval around the differences between the means. That's what we actually calculate, and we can draw conclusions on that. With those differences exclude zero, then we can reject the null hypothesis. But that's not what gets presented in research articles. In research articles, they will almost always instead present what you see in the bottom two pieces of the graph, individual group confidence intervals, the confidence intervals around two individual means. Now, a lot of people think, and a lot of researchers falsely believe that if those confidence intervals around the means do not overlap, then the results are statistically significant. Well, it is true. If these confidence intervals do not overlap, the results are statistically significant, but it doesn't need to be the case for them to not overlap for you to have a statistically significant relationship. So what does these confidence intervals tell us? Well, group one's mean likely to be something between 0 and 4. Group two's mean something to be likely between 3 and 7. So it's just a confidence interval expressed in a different manner. The confidence interval around the difference tests the null hypothesis directly. You just ask, is 0 in this interval? It's less direct when you have individual means with their confidence intervals. So some rules of thumb. If you get confidence intervals around means, you can draw meaningful conclusions. You just have to know how to convert them. First is you want to establish the margin of error. That's simply half of the width of the confidence interval. If your confidence intervals are of different widths, you can average them to get an estimate of the margin of error. Figure out how much the confidence intervals overlap each other, and compare the overlap to the margin of error. If the overlap is half of the margin of error or less, the group means do differ significantly at 0.05. One thing to note here is that all of this only applies to independent sample situations. If you're looking at confidence intervals around paired t-tests, you cannot use this logic. There simply is no way to visually interpret those types of confidence intervals. All right, so let's take a look at this. Margin of error. Well, that's going to be 2 because the bars are 4 units long. The overlap here is just 1 point, that area from 3 to 4. So 1 is half of the margin of error, meaning that we could reject the null hypothesis at 0.05. So a relatively simple procedure. We just need to know what to look at. Here in this situation, we have 2 confidence intervals that do not overlap. Again, group 1 and group 2 are the ones we would be looking at. Anytime you have that situation where the overlap is 0, you don't really need to interpret. And again, a lot of people think that this is the criteria for being able to reject based on confidence intervals, but it most certainly is not. As we saw before, you can have some overlap and still have a statistically significant difference. Here we see a situation where group 1 and group 2 overlap quite a bit. They overlap by about 3 points. The margin of error is 2 as before. Again, that's just the length of these bars divided by 2. So there, in this case, we would fail to reject the null. All right, so a few examples from the literature, and I think I specifically picked bad examples. Presentation and research articles can be a bit inconsistent. Most researchers will present confidence intervals around the mean. However, sometimes the graphs are hard to read. Sometimes the confidence intervals are margins of error rather than the bars are, I should say, are margin of error rather than confidence intervals. Sometimes the bars are standard error. Sometimes the graphs aren't interpretable at all with the information provided, or more technically, the information not provided. So here's a graph, and well, I don't think it's a very good graph because it's pretty hard to read, but you can see that pretty much all of these overlap considerably. But the comparisons that you want to make, the comparisons that we would want to make between the white and the black participants just can't be made because it's well, we'd need to do some work to interpret these to figure out which ones overlap and which ones don't. Maybe that's a better way to say it. So not a great representation here. All right. Here's one. These are error bars rather than confidence intervals. I'm sorry, these error bars indicate standard error of the mean rather than a confidence interval. So again, sometimes it's margin of error, sometimes it's standard error of the mean, sometimes it's the 95% confidence interval. Just the message here is be sure you know what you're looking at. What we've talked about is useful for confidence intervals, but not for those other two pieces. I would say here, though, if you see considerable overlap with the standard errors, that's a good indication that you wouldn't be able to reject the null hypothesis. All right, standard error bars. The standard error is the margin of error divided by the table two-tail value for 0.05, or probably, since we're eyeballing stuff anyway, a good shortcut here is you can simply multiply the standard error by 2 to obtain a good estimate of the margin of error. It's going to be twice the size. Anyway, why just 2? Well, if you look at the degrees of freedom and what the two-tail t value is, once you hit about 30, it's pretty much always going to be right around 2. So that's why that shortcut exists. All right, here's another example. Here we have the standard errors. We can multiply those standard errors by 2 to get the confidence interval. In this one, of course, they don't have the bottom part of the interval, so really hard to assess overlap again. Here's one where it doesn't really say what the bars are. What exactly is it? What am I looking at? It's not really clear, really hard to tell. All right, so that's a short piece on confidence intervals and their interpretation. If you're interested in reading more on how researchers get this totally wrong, there's some work by Fiona Fidler that's really quite interesting on this.